So how do we actually go about using this table in front of us, this Z table in front of us, to figure out some interesting likelihoods? So let's start with our three height scenarios here. So we have what maybe we're interested in the likelihood that a male selected at random is between 70 and 72 inches. Well, that is, as we've talked about now, that's this area, as I shaded in here, that's between 70 and 72. We're interested in the share of the whole 100% that falls within that window. And as we just learned, that's the same, or it's going to give us the same result as if we found 0.5, right? So the z-score here is 0.5. We can just rework that real quickly. So this is 72 minus 70 divided by 4 gives us a z-score of positive 0.5. Right? And so positive 0.5 being the z-score of that 72, we can now think about what percentage of outcomes are going to fall between 0 and 0.5 standard deviations on the standard normal. We know we can kind of set aside this 70 to 72 for a moment. We're now focused in on from 0 to 0.5. When we turn to the z-table, we can look up that precise answer. Now, the z-table, again, it's going to take you a few times to get comfortable with it. The way we want to read the z-table is that we have the first two digits here. So, we read this as 0.3, and if we wanted, for instance, if the z-score was 0.32, we would read 0.3, and then we would go over, this is 0.00, 0.01, 0.02. So 0.03 is down here to this row, and then we go over to the column of 0.02. So you're really rebuilding the 0.32, for instance. Okay, and that would be the answer we're looking for. Now, for us, we wanted 0.5, right? It was just 0.50. So we go down, we find 0.5, we go over to 00, which is right here. And so this tells us 19.15% or 0.1915. That might be hard to see. I can zoom in because we're right on the edge. Maybe I can't. So 0.1915. That is, what is that answer? That is a certain area shaded. Now, if we look at the Z table here, it reminds us what we're looking at. So the shaded area, or the number presented, is always this shaded area. Okay, it's not 0.4750. In this case, it's 0.1915. It's the range, or it's the area between 0 and whatever the positive standard deviation would be. So 0.5, or the positive z-score, I should say. So between 0 and 0.5 on the standard normal, we find 19.15%, or 0.1915. Right? I lost here's the 0.5. So we read the table, we find 0.5, and it was 0.50, so it's this value here. So that tells us, if we kind of go back here, let me get my z-table a little bit out of the way. That's telling me that this area that I have shaded in yellow here is 0.1915, or 19%, 19.15%. Okay, so there's a 19% chance that a male is between 70 and 72 inches. So what we're really finding here, what we really found was that there's a 19% chance that you're between 0 and 1/2 as a standard deviation. And we know that that's directly related to the other normal distribution. Okay, so we can take that finding and apply it directly to our male normal distribution. So we can do a similar thing. And what happens when we, let me just change colors here real quick so we maybe are less confused. Although plenty of colors here. I'm sure there's plenty of confusion. So what happens if we want to think about 72 to 65? Well, again, we need a z-score. So this z-score is 72 minus 65. I know we did this already, but divided by 3.5, which gave us a z-score of 2. So this is not, we're not interested anymore about 0 to 0.5. We are now interested in 0 all the way over to 2. Okay, so instead we want this larger shaded area from 0 to 2 standard deviations. Now again, we can turn to our z table. Let's see if I can get down there enough. And as we scroll down, again, we're looking for 2.00. So again, it's going to be in this first column because we don't have a hundredths place. It's 0. So we find 2.0, look over to 0, and it's 0.4772. 0.4772. Whoops, that's not what I wanted to do. Okay, so we'll set that over here. And so what we've learned is that 0.4772, or about 47.72%, are within 2 standard deviations, from 0 to 2 standard deviations. Again, this is measuring. If you forget, you can always glance back at the z table, and it reminds you that that value is from 0 to whatever the z-score is. And in fact, this is very close to the z-score up here. You can see that at 1.96, the answer was 0.4750, and we got 0.4772. So it's slightly larger, right? So I don't know if you can see my cursor, but it'd be, in here, there's a little bit more sliver that isn't in this default picture. Right, but that would tell us 47% of females are between 65 and 72 inches. And now we can let's do this one more time for the, I think we call them synchronized swimmers. This is 72 minus 67 divided by 1.5. There's a point in there. It's not 15. And that gave us 3.33. So it's 5 divided by 1.5, or 3.33. So again, thinking, I know there's a lot getting drawn on this, but that is, we now want to measure all the way out to 3.33. So we can assume that this is going to be larger, right? It's going to eat up more space, but how much more? Well, let's go look at the z table. So we have hit some limit of the z table that we're working with, in that it does not extend all the way to 3.33. And in fact, it ends not much larger than 3. Okay, so at 3, we can go down to 3.09. So 3.09 is way down here in the corner. 0.4990. So we hit a limit as far as what's displayed in the typical z table. Now that doesn't mean we can't find the answer to that. And in fact, you could just plug it in nowadays into Google and get the exact value. But we can take from this that it covers almost 50%, right? So it's going to cover 0.499 and then even more than that. So we would want to, I mean, if we want to be very specific, we'd want to look up the exact answer elsewhere. But that highlights some of the limitations of the z-score. Again, we could put even more into this table, but it would get more expansive and be quite cumbersome. So what else isn't in this table? Well, notice all of these are positive z-scores, but as we mentioned, negative z-scores exist. It's simply somebody being below the average, right? So what if instead we wanted to think about just somebody below the average, or what's the chance? Let's start with what's the chance that you're between. We'll go back to the first example, the male, somebody between 64 and 70. Okay, what is the z-score? Remember, this has a a standard deviation of 4. So we're interested in the share or the likelihood that a random individual would be between 64 and 70 inches. Let's put it into a z-score. So the z-score here is 64 minus 70 divided by 4, which gives us negative 6 over 4, which is negative 1.5. Okay, so how do we handle that? Well, first we know we're dealing with the normal distribution. Okay, from 0 to negative 1.5. And we can look up this area on the z-table. Except we can't seem to find negative 1.5 here, right? They're all positive. So here's where we need to rely upon one of the keys of a normal distribution, one of our key properties, and that being the symmetry. So we know the normal distribution is symmetrical, right? This computerized version is more symmetrical than my hand-drawn ones, but they are symmetrical. And so what that means is that the likelihood of being between 0 and, say, positive 1.96 is the same as if you were thinking about 0 and negative 1.96, right? So going either direction from the mean gives us the same likelihood. So we can use that to our advantage, and we're using it to our advantage because we don't have to replicate this table for the negative numbers. It would look the exact same if we had just the negative numbers plotted out. So we can say negative 1.5, we come down to 1.5. That tells us 43.33% or 32%. So 0.4332. And that is, again, that's technically, or what we're seeing in the let me get this out of the way. What we're seeing on the table is technically this area, from 0 to positive 1.5, but we know that because it's symmetrical, these are equal. And so we can say 43% are between negative 1.5 standard deviations and the mean. That brings us back, and we can then apply that to negative 1.5 standard deviations for the male height is 64 inches. So 43% are between 64 and 70 inches. So those are some of the tricks, especially when you're dealing with the z-table, that we'll need to keep in mind when we go into factoring this or into answering some questions, because it would just be very cumbersome to include all of that. So the z-table assumes that we can make those types of connections. The other big, so two other things. What if we weren't worried about 64 to 70? What if we actually were thinking, okay, what percentage of men are below 64 inches? Right? What, I should have maybe translated that. What is that? 5'4"? So what percentage of men are below 5'4" inches? So 64 inches. So we would go through the same process. We found that z-score already, right? It's negative 1.5. But this time we're interested in not the share that's between, we don't care about this anymore, right? What we're interested in is this area over here. What percentage of men are more extreme on the low end of the height distribution? 64 inches and below. Okay, so we can go and use the same z-table. We would look up again, negative 1.5. We'd get our same answer. So this clearly isn't the only step we have to do, right? So the same answer is 0.4332. So here's where we rely upon one of the other big aspects, or I guess it's the same. It's symmetry within the normal distribution, in that half of our likelihood is below the mean. So 50% is to the left of the mean. So what does that mean? Well, we already calculated that this area is 43%. So I've clearly not drawn this to scale. But we've calculated that this area is 43%. And so that means that this remaining area must equal up or total be the rest of the 50%. Okay, so we can use the concept that 50 minus 43.32, that's going to give us what? 6.68. So 6.68% of men are below 64 inches or 5'4". Okay, so we had to use a couple tricks. We needed to know that we could use negative z-scores and look at the positive z-score table. We also needed to use the trick that half the likelihood is below the mean and half is above. So we know that the bottom part here is 50%. And then we can subtract off that 43% that we found previously. So a couple tricks along the way that had to be employed to get us to the end answer. But again, all of this is so much easier than going through the painstaking process of reintegrating every time we come to a new distribution. And then lastly, I'll just touch on the other concept that we're going to want to be aware of, and that is, what if we're not relative to the mean or to the extreme values? So what if we're interested in the share of, let me just get this out of the way. So what if we're interested in the we'll go to just a lot going on there. So what if we're interested in the share of women? So this we know that the women had a 65 with a standard deviation of 3.5. And we are interested in women being, we had 72, so we'll rely on that. So 72, and let's do 70 inches. Okay, so we're interested in this little sliver. So how do we go about doing that from our z-table? Well, we have already done a little bit of this. So let's just remind ourselves the z-score of 72. Let's just write z of 72 is 72 minus 65 divided by 3.5 gives us, if I move this out of the way, gives us 2. The z of 70, if I could write legibly, the z of 70 is 70 minus 65 divided by 3.5. So that is 5 over 3.5. Somebody can probably do the math in their head better than I can. So that is 1.43. So it's 1.428. But we'll round it to 1.43. Okay, so this is going to take a few more steps. So we know we've already looked up the likelihood of being between 0 and 2 standard deviations, right? But we could go back to the z-table and find that. That would be right down here at 2.0, and that's that 0.4772. Okay, so that means 47% are between the mean and 2 standard deviations. But that is not the answer we're looking for. So what we need to do, remember, we're looking for this little sliver in here. We want to know between the mean, or sorry, not the mean, between 1.43 and 2. Right? So we want this middle sliver here. So what we need to do is subtract off this extra part. So we're going to look up what the yellow is here and take that away. So we know the orange, it's kind of overlapped here, but we know the orange is 47%. What is the yellow? Well, let's look up 1.43. We go to our z-table, 1.4. Let's go over to the 0.003. So this is 1.43 is 42.36 or 0.4236. 0.4236. Probably could have color-coded this a little bit better. But now the difference between these two is this red area here. Right, so we have 47% as the larger chunk. We have a 42% is that yellow chunk. And what's left over is the red in the middle. So that is going to be, what, 0.053236, if I've done the math correctly. And so that tells us that 5%, 5.36% of women are between 70 and 72 inches. Or more generally, if we ever have 1.43 standard deviations above the mean and 2 standard deviations above the mean, it's going to be a little over 5%. So the process can get a little complicated, okay? And this is these are with positives. Sometimes we're going to have to deal with negatives or the outside parts. So we kind of, as you approach a problem, you need to be able to incorporate all of these different little tricks. My suggestion is to always sketch it out. So even after doing this thousands of times, I still sketch out a little normal distribution for myself just to keep track of, okay, I want to be, I want to factor this in all the way to here. So I want this range. So what do I need to add up? So, start getting in the habit of sketching these out for yourself, even if it's just on a little notepad. Can really help you keep track of what different calculations and looking up on the table you need to do. But that's kind of how we go about using the Z-table to answer certain questions.